I'm here today talking with Dana Korf, AME Standards Manager at Nano Dimension. You may know Dana from the Dana on Data column in iConnect, and I've seen his column many times, and most recently he put out a very interesting article on using ChatGPT for data transfer. It's very interesting to read, and I think he and I came to some of the same conclusions. So we may talk about some topics in data transfer as well as what he does at Nano Dimension. Dana, thanks for joining us.
Sure. Thanks, Zach. Thanks for having me today.
Yeah, absolutely. Thanks for agreeing to come on the show. I've never talked to you personally, but I have read your column. And I didn't realize you were working at Nano Dimension until I actually spotted you on LinkedIn and saw Nano Dimension there in your tagline. So maybe if you could, tell us a little bit about your background, what you do professionally, and then what your job is at Nano Dimension.
Okay. First off, relative to Chat GDP, everyone in the board industry has job security. Don't worry about it for a while. We're in good shape. So.
Agreed.
Yeah, so I started work 45 years ago now. I'll give the Cliff Notes version. Started out in the mini computer industry, and as an analog designer, got into circuit boards and layout back when we did hand tape ups, and we built our own board shop. I was responsible for developing propagation times for high-speed Schottky at the time, and crosstalk manually on paper. Didn't have simulation tools yet. So along the way, I've worked. I worked about 17 years on the OEM side, doing mini computers, high-end computers design, telecom design, including some of the one of the two first fiber to the home trials back in the late 80s. Back when it was illegal to broadcast cable TV and phone on the same network. So that was interesting. We found out you couldn't route fiber optics into a building because the electrician would wind it up like copper wire and stuff it back in the wall. And you say glass didn't like to be wound up and stepped in a wall. So then I went into the board. Along the way, I started a company with some folks out of Tektronix called ITI. We were the first laser blind via drilling contractor in the world, as far as I know. We also did a PC board layout using Cadnetic software, ring a bell, surface mount assembly. So it was kind of before EMS term got invented. So that was kind of fun, starting something brand new, and learned a lot about how not to do a startup company. That was a good life learning lesson during that period. And then I spent most of the last 20 some odd years in PC board fabrication, working with companies like Zycon, Hadco, Sanmina through acquisitions. I was responsible for R&D, buried capacitance for the first couple of years, among other things. So it's interesting. Our first laser drill we got was actually removing solder mask on pads. Found instantaneous ROI. It worked great. And then about about 12 years ago, I got an interesting phone call to move to China to work for a little company called Huawei to be their PC board expert over there. So I went over to China for 8 years, actually lived there and worked there. I was responsible for all board technology, cell phones through power supplies, through high-speed digital, everything. Over there, we were doing 4.5G, 5G, and 6G back then. The infancy of 6G anyway, work. Trying to figure out how to get a signal across the backplane, make sure it made it more than 5 inches. And then after 4 years, I moved over to Multec over in Zhuhai, China, and spent just under 4 years there, again, running their front-end operations for the 5 facilities there. And then retired back in 2019 for about 3 weeks and got into focusing on what project are retired PC board people not working on? Data quality. So I said, that's my focus for as long as I can walk. Yes, how are we going to get data quality improved and data transfer correct? Then I did some consulting jobs on the way with various companies, including a couple Altium competitors and some OEMs. And then Nano Dimension called me up, said, hey, this is a new industry. We're fully building 3D circuit boards with silver ink and dielectrics. There aren't any industry standards out there. We hear you like IPC standards. So, okay, yeah, that sounds like fun. So that's what I'm working with Nano Dimension, and IPC just started last month the official committee work for 3D AME standards. We have a very good suite of companies and people involved in the creating of these new standards because they're going to be a little bit different and a little bit of the same. So this ought to be interesting over the next couple of years.
So you're really responsible for the for Nano Dimension's input into those
actually
committees.
more of the responsibility for the output of the machine. You take your substrate off the machine. Is it good?
Sure.
There's nothing that says whether it's good or that bad right now. So I'm responsible for that. Then of course I'm heavily involved in the data transfer portion of the industry because it's very nascent and out of control right now. So it's very, very paper based, just like PC boards are right now. So I'm working on that for both with ASTM. And so we have 2581 as a good standard out there, and we need to bring more 3D activity or data into that. So why reinvent this? So we have the AMF standard from ASTM, pretty good. Actually, it's very good for sheet metal and metal and plastics, and trying to see can we merge these together somehow. We're in the very initial discussion phases of that, and trying to see how can we create a true single file format that contains everything before this industry takes off too much, and try and solve a problem before it occurs. So that'll take a few years. That's okay. We'll figure it out.
Yeah, I'm seeing two threads here, right? There's the data transfer standard as it relates to AME, but then I think you also brought up like qualification. You mentioned, is the board good enough as it comes off the machine? And I would have thought, not being someone that works in the additive industry, that there would have been an IPC standard that was sufficient enough to at least telegraph itself onto additively manufactured electronics. That's not the case.
But it's kind of half the case. So what I did last year, I said, okay, let me take 6012. That's the base spec for rigid boards. What's applicable? Well, when you go through the spec, about half of it falls out because you don't drill holes. You never remove material. You don't have copper plating, remove all that stuff. You don't create layer cores in a process and a few days later try to stick them together in a press. That doesn't exist. You don't back drill because if you don't want material there, don't print it. And on and on and on. Solder mask is an interesting area because you don't need to print a secondary solder mask. You just print your dielectric up over the traces. That's the same thing as a solder mask, except it's the same as the dielectric. So thought about it. Well, it has the same function as a solder mask. It needs to meet the same end product things, but how you get it there and registration is always perfect. Print right next to the pad. So there's some assemblies, but then on the downside, okay, we print things in slices. So you have 2 layers right now. It's a core, resin glass and 2 copper. Well, now we might have 100 layers between there, call them slices. So what could happen when the slices print over each other? So we got to figure that out. And how do we document it? What's good, what's bad, etc. So yeah, so you're correct. Your base assumption is correct. It's based on existing boards, but it's different. Yeah.
Sure. No, I can understand, especially once you start to look at the internal structure, as you've mentioned.
Yeah, and trying to make it so it's process agnostic. Who cares how you do your additive? Just when you take it off the machine, how does it need to perform? See if how long we can hold that thought out there. I think we can.
Okay, but I know with Nano Dimension, it's essentially material aerosol jetting, I believe. It's that kind of process.
No, ours is right. Well, we have a bunch of sub companies, but the main company I work for in Nano, we actually have the inkjet process right now.
Okay.
So we have other processes in other divisions that are more in metals and plastics, and they're looking at combining materials now to make circuit boards. So, and we also have an artificial intelligence company, which is interesting because in the machine, AI actually watches the process real time. You don't have humans pulling cross sections at all, and some of the military folks are having a problem in letting AI do the work instead of humans doing the inspection. And this has come up in the AMSC roadmap activity we're just finishing with ANSI. Is a lot of people in the industry is going, we have to rely on AI, folks. We can't inspect everything anymore. We can't make 5 extra pieces. Like someone just shot a rocket up into space. They built the whole thing in one piece. You don't build 4 more to cross section.
So the other area that you work in is data transfer. And
Mm-hmm.
I think when most designers think of data transfer, they of course think of all the manufacturing files that they compile into probably a zip file, and then maybe they email it over to their fabrication and assembly house, and they say, "Hey, fabricator, figure it out." Is that an
Mm-hmm.
appropriate way to describe the modern state of data transfer?
That's a good way to put it. Yeah, it's not quite so black and white, but from the basic premise, you're correct. Yeah, I put
Well,
everything together Friday night before Thanksgiving, and I have to get it out of here. Good luck. Yeah.
yeah, and I'll admit, the way I package up stuff into a zip file to give to a fabrication and assembly house, um, I do tend to overgenerate data and then give them everything and just tell them, hey, the thing you need is in this folder. Here's the BOM, things like that. And I try and make it clear for them so they know what it is they're looking at and maybe provide some notes. But I think everybody doesn't really do that. I think it's all too easy to just go onto a quote form, upload your zip file, and then expect that the fabrication or assembly house can just read your mind.
Yeah, we can talk. We can discuss what's different between DFM quoting and really building something. There's different things that go on. They're all valid in a way, but you have to be careful how you use them. When I thought about when I came back to the U.S., I really thought about what's the core problem here. What are we trying to solve? Just for reference, many years ago, I ran a survey across thousands of part numbers, and a friend of mine who worked for a competitor ran the same analysis, totally independent of each other. We came up with the same answer, and roughly our analysis showed that roughly 5% of the data packages that a fabricator would get, we could use as is. It doesn't matter in the data format, is use as is. They're actually okay to build. Okay, so I said, well, what's the real problem here? I don't know any board designers that intentionally design a board wrong or bad. I don't know if that person exists out there. So what's going on? So if you break it down into really kind of three basic components, you got the fabricator or the assembly house. They have a set of design rules that when you send the data to them, they run their DFMs against. Now, not all board shops have all the rules written down, especially in Asia. Saw this problem a lot. Was engineers are afraid to get laid off, so they want to keep the information in their heads. So they don't tell the front end what it is. You have to call them up. Okay, so how can you tell a customer what the rule is if the factory won't tell you what the rule is? Now, one problem. So I said, okay, and a lot of factories, I should say companies, think of the design rules as IP. And I've done this over the years with various presidents of companies saying, no, the design rule is not the IP. It's how you build the board is our IP. We want the customers to know how we want it. Why would we keep it secret? Okay. So there's that end. We got the data transfer piece, bidirectional. Okay. So there's no way for a fabricator to easily send the rules back to a user to load into their CAD system. That's not defined anywhere in the world. Okay. And then you get the data package coming across, like you mentioned. You get a whole lot of files packed in that zip file, and it's not uncommon for them to have a difference between them. Okay, I call it the multiple master problem. Okay, and I'll come back to that in a second. So you go back to the CAD system side. Think of the CAD tools, the simulation tools, and you think about the DFM tools. They're all there's different ways to do this. Don't worry about that. Think of it as one package. So can they actually, if I gave them all the design rules that I used as a fabricator, can any CAD system, DFM system review them? The answer is no, they can't. They don't. So even if I gave everyone the rules, they can't use them anyway. So there's kind of a three-stage problem here. A good example, like I gave a speech at IPC a few years ago at Apex and talking about data transfer problems and conflicting masters. We had a room full of designers and fabricators. I asked the question, I said, okay, as a designer, you send me your Gerber file and you send me a fab print, okay, and the outline dimensions are wrong. They conflict with each other. Which one should I use? And unanimously they spoke up and said Gerber file. Then they all started laughing, just spontaneously. It's like, I have two documents here and they conflict. So which one really is the master, right? And so we had that problem at the time. Netlist always have problems. Actually, the Netlist standard has an error in it. We fixed that in 2581. I think Siemens has now fixed that in their ODB++. Where if you join an analog and a digital ground together on a board, we get a netlist error. Okay. 2581, we said you can tell us it's intentionally shorted, so we won't flag it as an error, things like that.
Yeah, in your CAD tool, you have to create a net tie that
Right.
is essentially a component, but it's just copper.
Yeah.
And then it creates that short.
Yeah.
Oh, yeah, of course. They don't.
Yeah.
They just draw in the connection between the nets on the PCB, and then they try and keep the polygons separate, and then they draw a trace. And then that's it. Something like that.
Yeah. So I kind of break it into kind of 3 steps here that are all kind of not linked very well together after 70 years of doing PC boards in the world, 80 years. Yeah.
So I'm seeing this become a problem on multiple levels, right? There's the process problem, because if your process was correct or maybe better, you wouldn't have this issue with conflicting masters, right? You wouldn't have conflicting drawings with Gerbers, with ODB, with BOM, with all this stuff. There wouldn't be all these conflicts.
Right.
There could be an issue maybe with the ECAD systems. Maybe the CAD systems could do a better job of ensuring that these masters are all consistent. And then maybe there is an issue with understanding on the fabrication side or on the design side what the fabricators want.
Yeah.
I think there are different ways to solve this, and really it sounds like we need something standardized, which is maybe where someone like yourself comes in. So how does IPC 2581 maybe try to address some of these problems? Or does it at all?
Yeah, 2581, we started that activity in 2000, literally it's not an AME project. Valor donated ODB++ XML to start this activity along with the GenCam from IPC, which it was all intent purposes was a throwaway, except for 356. And so we started looking at what was missing. We built it up over time. The concept was to have one file. You only pass the data parameter once. You don't pass it twice or 3 or 4 times. So in 2581, and I'll get to a couple other factors too, but in 2581, if I have a net, I can say what the material is. I can put in what the surface roughness is, top, bottom, and sidewalls. I can put in what the impedance is, what the impedance tolerance is, what all the line width tolerances are. I can tell you on a pad what the surface finish is or surface finishes, all in the net description. I don't need a drawing to tell me that. I can extract it from the data file actually. If I have solder mask, I don't have to put a note on the drawing saying use IPC SM840 type blah blah blah. You just on your solder mask layer say IM green solder mask per IPC blah. You don't need another note, because a lot of the problems are humans who don't speak English very well and pick your version of English you want to use. They have to read these things and type them in someplace because automation can't read it. So the premise was let's get everything into one file. And we're almost there. We're not quite there yet. I'd say we're probably 90%, 95% the way there. We're working on the Rev D right now. So that's one. Everything going to one file. You can put dumb notes in. I created a sub team a couple of years ago with several people. We created intelligent notes. So you could actually, if you wanted to put a note in the drawing, you would be written out using attributes from the 2581 file if you wanted to write a note. Conceptually, you think of a fab print as a report. Think of it as a report. Right now, we use it as a form transferring data like impedance information. But you don't need that with 2581. You don't need a stack up picture. Don't want it, actually. And with the 2581, you can send your stack up across. And you can have your picture at the design side or your customer design side, have whatever picture they want to look at, send that attributes across, and I can look at it in whatever picture I want to look at. Right now, the fabricator may have to do a stack and create 2 or 3 different formats and send it back because everyone wants their picture. Just run some software and create a picture. That's the easy part. And then 2581, you can include the different versions that go back and forth in the file. You can record them all. It's native to the format. And in the last release, we actually incorporated in Rev C version the function of a DFM report. So your DFM report, DRCs can go back and forth electronically. You don't need to send emails. You don't want to send emails. You can send it back. You can click on it. It'll pull it up in the CAD system with the CAD system dimensions, locations, different than the fab. So you can send that data back and forth. One of the big problems you have, especially boards that are 20 to 30 years old, and you get a phone call, hey, you built this board for me 20 years ago. Can you build some more? So we go in the archives, we pull it up. Okay, we found the file we used. Well, who approved those changes? We don't know. Your guy has the email. Well, he died. We don't have his computer.
Yeah, right.
Okay. So who has the master now? Everyone has a master at that point. Every fab has their own master. And then the other thing on IP security, I just went through on LinkedIn with a conversation with somebody. Maybe you were on that conversation about IP control. In 2581, we established on day one the concept of function modes. So you have your silkscreen layer, your artwork layers, your netlist, bombs, AVLs, test files, blah, 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 all have distinct layer, function modes defined. And if you want to send a file that has just these silkscreen layer for a screen print, just send that. Just pick this function mode and send it off. If you want to send to Fabricator only fab stuff, there's some FOD mode, send that off. We don't care about the AVL and all that. So we actually don't want it. We don't want the schematic or anything. And so we handle some of the IP that way, so you can have everything in one file, and you don't have to send the file to everybody and lose IP control. So those are kind of the core concepts, along with flex, rigid flex, cavities, embedded component mounting, all that stuff is in there now. So it's a pretty thorough format. We're working on including GD&T dimensioning right now. How are we going to incorporate that? That's one big area we're working on right now with JEDIC guys, trying to figure out. We don't want to duplicate anything. We want to try and use what they did. So
very interesting. And I'm going to admit I don't use IPC-2581, but part of the reason for that is because all the fabricators and assemblers that I work with, none of them use it, right? The fab guys want Gerbers, and I think part of that is because 95% of their customers are giving them Gerbers, so they just kind of throw up their hands and say, screw it, give me the Gerbers. And then the assembly guys like the ODB++. So I always just generate both directly at the same time to make sure that they are consistent, because, you brought up the issue of one set says one thing, the other set says the other thing. You at least want to make sure they're consistent, so generate them at the same time and then hand them off. So those are the formats that I use, and I think a lot of designers are like that, but it seems like the issue here is that either the design community doesn't know enough about this and the value, manufacturers don't know enough about this and the value, or everybody is still stuck in the past because that's what they've been doing for the last 15 years, and there's no impetus to change. So why am I going to stop generating Gerbers?
Right, yeah. Humans hate change, which is normal. Actually, the stats we have is IPC-2581, we think, is around 5% of users actually using it. ODB, according to them, is around 20%. So after 20 some odd years of two intelligent data formats, 3/4 of the world still does it. In Asia, it's funny, you talk to a board vendor, send us your Gerber file. I want to send you 2581. Yeah, that's Gerber. They call everything Gerber files. Doesn't matter what the format is. Because that's all they know. It's called Gerber. No, it's not Gerber. It's not Gerber at all. But yeah, when we did 2581 at the INEMA, we decided we needed a couple large OEMs, and we needed the CAD and CAM software people involved. Otherwise, it's not going to go anywhere. You got to have a few people make it. Now you're seeing large companies, actually there's already many, that are requiring 2581 to the vendors. As a fabricator, I can't make anyone do it because I'm not their customer, okay? But if a large company comes in and tells me, the fabricator, in 12 months, I'm not seeing you Gerber anymore. You're going to take 2581. Everyone figures it out. I'm going through one right now with a company right now. Say, we're just going to tell your vendors you're not going to send it anymore. And guess what? It'll work. Trust me. Been through this on both sides many, many times. Yeah, you're right. And people aren't feeling the user doesn't think they're feeling the pain. It doesn't cost them enough money when it fails. But in reality, it actually is costing them money in cycle time.
So everybody will figure it out eventually, as long as there's enough push, maybe from customers or from vendors, like you've said, to move to this more modern format.
Yeah, because it requires less human typing when you get the data on both ends, and that's a defect reduction flat out. Yeah, can't trust humans.
Yeah, and I'm sure it will be very nice for people who have to manage this whole process to maybe shorten that email chain significantly if they can. I mean, I know
Yeah,
whenever I have to deal with a fab order, um, I feel like there's just going to be a stream of emails for the next week.
right.
Some questions, ordering parts. Can you clarify why you didn't include this layer? We see this in the design file, but we don't see it in the Gerbers. On and on and on,
Yeah.
and it's always something.
And the worst part is the companies, especially in Asia, they're very customer centric. So they don't want to irritate their customer. So they don't ask 9/10 of the questions that they really have. They just make an assumption. And you never hear about it until you get a board in that doesn't work. And you go, why didn't
Yeah,
you ask me a question? Some designers, to be honest, hate having questions coming back because they're busy on the next revision. They don't want to work on it anymore. So they kind of push people. Don't ask me questions. And I ran my groups between the various companies we worked for. I figured we saw probably over 1 million packages come in over the years. Okay, and our rule was ask the question. I'll take the abusive phone call. We want to get them a board that works, not just manufacture, one that actually works. And it's okay. We'll take the abuse. They'll fix things after it becomes painful enough. And so, yeah, that's kind of an interesting problem.
yeah. I don't produce overseas hardly at all, or if I do, it's through a contract manufacturer, and they're ordering fab from a vendor overseas.
All right.
Um, but you brought up the assuming part.
Mhm.
Man, that's the worst, and I'm dealing with that now with the Canadian assembler, who shall remain nameless on this podcast. But they they assumed the polarity of a reversible connector, and we've emailed back and forth about just about every other aspect of this board for the last however many days or weeks. Like, you could have just asked me what's the correct orientation of this connector, because for whatever reason this pin 1 marking didn't make it onto the board. And
Mhm.
it seems like something so simple, just asking, and yet fabricators still assume how the board should be built or how parts should be assembled.
Yeah, when at one point in my career, we had 22 companies that were merged together. And so I was in charge of the front end engineering. I said, let's do a test. Let's take one part number, send that to every board shop, pick your best front end person to review it. And we're going to collect up all the TQs, deviations they come up with in a bucket. We're going to analyze everyone together. And out of everyone, we came up with like 140 some odd different questions. Only one was common to everybody. That was, can we feed the board?
Wait, can you what? Thieve
Can
the
you
board?
feed the board? Put thieving around the outer layers or inner layers. That was the only question that was common to everybody. Stack ups were different, edits were different, recommendations were different. So there's a style to this, unfortunately, because people know what they know, right? And what they get trained on. Yeah.
So this is interesting, right? Because it illustrates, I guess, how different CAM departments are going to look at a build that comes in, and maybe make different assumptions and maybe review the information in different ways. I'm wondering if the issue that you've just brought up is one of the reasons that some companies will over specify just to death almost. And whether it's in the front end engineering document or whether it's the back end build document, they over specify everything. And even that becomes an issue because then you get a 20-page document with specifications, and it's like, well, what CAM department wants to read that?
All right. So that's a very good point. So in the higher, I worked in higher end board shops in general, not very low end ones. And I was one of those people that and a lot of our management team said, we're going to ask everything. Why do we do that? We don't want any scrap in the factory assigned to our department. We never want a return coming back saying it was a question we didn't ask, you know. So, but I've worked with many OEMs on this very conversation and CMs. I'll talk about the CM issue in a second. Okay, so we have 20, we're getting consistently 20, 15, 14. Every single time we do a board, we get the same questions. So we've worked with customers to say, let's work a general specification. Let's just put these forcing questions that are common into a spec. Let's work out what the answer is, and we never have to ask it again. If you're not going to fix your process, if it's a design related issue, if we're not going to change our process because it's a unique request, then let's come up with the answer is. So we have the answer formally approved by the OEM, by the designer, and we don't have to ask it anymore. We just include that as a spec, just like IPC specs, everything else. So we can reduce the number of questions that you can do. And actually, that's not that hard to do, believe it or not. If you really pray out a bunch of like 4 or 5 part numbers from a supplier, or pray out 4 or 5 part numbers across 5 suppliers, there are really a lot of common ones that probably you can decide I really don't care, or I absolutely care, and the vendor can go, oh, okay, so maybe if I change a little bit, is that good enough? Yeah, okay. Then we don't have to ask it anymore. So you get the questions asked and answered without having to ask or answer them every time. Instead of both ends fixing the process. And CMs is a very good point. So a lot of times the designers like you and your company, you hand a board off to an assembly house somewhere, and maybe two or three assembly houses. You don't know who the vendor is going to pick, the fabricator is, because that's their job, right? So it's kind of hard for you to design to the fabricator's design rules because you don't know who it is. And that's not your fault. That's just the process fault, right? A lot of big companies will specify here's the vendors you have to buy from, so it kind of helps you knock that problem down more. And also too, if you think when a quote comes in, we mentioned quoting a second ago, you get a quote. Okay, you just have a one-up image of your board. You get a quote. I put as many up on a panel as I can. I give you a price. It goes to the CM. Well, actually, they want 3 up or 4 up on an array, so I have to add all the rails to it. So instead of getting 20 in a panel, I'm getting 16. But your price just went up. You're irritated at us for raising the price, and it wasn't our fault, right? Yeah, that's not something you can control necessarily as a designer. Not always, but sometimes you can, but maybe not. And that's always a problem too.
Yeah, the automated quoting issue, I can see something like IPC-2581 being valuable for that because I've used, one of the reasons I like some of the fabricators and assemblers that I've worked with is because they have an automated quoting system. If it's a last minute thing or you just can't wait for someone to email you back and forth to try and get a quote, you can put your stuff into their website and it generates a number and you can start
Right.
budgeting off of that. Of course, a week later when you click submit and you pay for it and then they say, oh, it actually costs 20% more because we didn't know A, B, and
Right. Blah blah
C,
blah. Yeah.
everybody's irritated.
Right.
And
Yeah.
with assemblers, I've had this happen multiple times, which is I'm just going to be honest to all the assemblers out there. I don't have the number of QFNs in my design memorized, but they're billing you more if you have QFNs. So every QFN costs a little more money, and suddenly, you think you have 5, you actually have 8. Now your assembly run just went up by 10%, let's say,
Right.
and that can be a significant amount of money. And when you're budgeting based off of the numbers they give and they can't tell what packages you have, uh, it's difficult, right? It's difficult to maintain your margin. And I'm wondering if something like IPC 2581 can help with that as well. Can the package specification be built
Sure.
into the design data?
And rotation, upside down, right side up. Yeah. In a
Okay.
cavity on the surface. So does it mount this way or that way inside the board? Oh, that's in the format. Yeah. So you could there are some prototype shops in the U.S. that have automated quoting because when you're doing quick turn, you're being paid for speed and it'll work good enough. That's what you're being paid for. To go to production, you're paying for yield and long-term reliability. So they don't need as many attributes to quote a job because they have a wider process window for the technology that they run. So they're not trying to get to 97% yield every time they run it, getting to enough yield to get it out in 2 days or 3 days. And that's okay. No problem with that option. But the problem you see when someone transfers the design from a quick turn shop to a high volume shop, they go, well, the last guy didn't ask that question. Well, number one, he didn't have to because that's their business model. It's okay. Okay, we have to know these to get a high enough yield. Or like one customer many years ago, he sent me a job. So you have to use my material. I go, we can't get that material in Asia. Well, I build it here in New Jersey. Why can't you get it? Because the vendor doesn't ship that material to China. We physically cannot get it. But I'm FDA approved. Well, I don't know what you're going to do. You're not going to build it in China. You know, it's like you got to be aware of the differences between regions when you're transferring between different continents because there are a lot of differences. And
Yeah, I can see why there's a lot of confusion that arises, especially you brought up scaling. Now, when you want to scale up to, let's say, instead of 100 units, it's 10,000 units, um, you need to be able to ensure quality, like you said, but then you also need to ensure that this whole process for ensuring quality is actually as smooth as possible. And so now you need to make sure your data package
mhm.
is immaculate. so that they know what it is you're actually trying to build. And I think this is, again, where someone will say, well, I'm going to ensure quality control with a very large specification document that outlines everything. What quality team is going to take the time to read through that?
Yeah, we did, because we missed one line. You'd lose literally $500,000 scrap. You missed this line. I always laugh in IPC specs, other specs says, here's the documentation hierarchy, order of precedence, purchase order, data file, drawing, blah, blah, blah. In reality, in the board fabrication area, we have to compare all those together. And in those companies, we have to always tell them everything that's different, because the second you assume, you're going to assume wrong. And so I always laugh at order of precedence. It's totally irrelevant. We have to compare everything, including the main spec. In large companies, there's a lot of designers and contract designers that work for them. They don't know the internal spec. They don't know they're violating it. Like the customer may say, I have a 4 mil minimum dielectric thickness requirement. They design in a 3-core. Okay. If I build it that way, I eat the boards I just built. Okay. It's not the designer's fault. It's my fault. A lot of times you actually can tell when a company subcontracts one board that's different from everything else, because you just don't know. Especially, you go offshore to get a design done real quick. And when they bring in new designers, you always go through this exercise. Okay, you don't know your spec. We're going to teach you what your spec is, because I know you're probably not going to read all the specs. Large companies have maybe 10 or 20 specs you have to buy for. And it's like, you have to know.
Yeah, as a designer, you've already got enough to deal with if you have to read the front-end engineering spec, and that could be a 50-page document. And now I've got to read your fabrication spec too. It's a lot of bookkeeping.
And quoting, the CM will send a quote out to 5 vendors. Whoever replies first gets the order. So everyone's goal is to get it out of there fast. All right. So rarely ever do a customer send all their internal specifications with the design package from the assembler, because they may not even have them. Okay. When the job shows up, like I said, now it's different because no one knew that was going to be a problem. And, chaos goes out over the price and the delivery times. Yeah.
Yeah, so I'm learning a lot here, that there's a lot of data transfer pains still going on, even though, one of the new buzzwords in the industry has been digital transformation, and trying to ensure that there are these seamless methods to collaborate between manufacturer and designer, or designer and test engineer, designer and front-end engineer, whoever. It seems like these data packages, it seems to me that the data package has been a real problem for a long time that no one's addressed, and certainly no one's addressing it on the collaboration front. I mean, we have design tools that work together. You have mechanical and ECAD collaboration that can work together, and you can, build in that kind of collaboration. But all of a sudden, when it comes to, manufacturing, we're kind of throwing it over the wall and hoping the fabrication house and the assembler can read our mind a little bit, and that there's few enough errors that we can just say, don't worry about it, put it through, and we're good to go.
Yeah. And there's a lot of, a lot of companies have field engineers remote from the factory to work with customers, one-on-one on high-level issues, make it high-level. Like a lot of these guys, these people typically can do stack-ups, and they're fairly accurate with the factory. Okay. But when you do a preliminary stack-up is a good example. You say, I'm going to have a 12-layer board. Here's my impedances, my line widths, whatever the constraints are. They'll do a stack-up for you. And here's the thicknesses. But you can't really calculate the actual thickness until you get all the retained copper percentages on each layer, because the pre-preg will squish up and down. And that could change impedances. That could throw a lot of things out of whack. But you don't know it before you start, which is kind of a built-in problem. But you can get close to not having anything at all. And but these folks generally, they're paid pretty well. They don't have time to sit there and run the DFM software all day long. They're out there trying to get more customers, help bigger problems. And so they can get it close, and then it has to be handed off to the factory to do stuff. And I've created a couple of cases where they could hand it off. We'd get back a DFM. We dedicate people to doing that. Get back the TQs back overnight from Asia, or a couple hours if we needed to. And but it wouldn't be a real formal, let's type it all up. It would be more of a quickie thing. And we would know what issues we could just fix and be okay. Things like line width adjustments to some extent. Though with 5G and and 6G type signals that are a lot more becoming RF signals now. So even line width adjustments can be dangerous, or rerouting the trace can be dangerous, or adding a pad, deleting a pad can make a circuit not work, as you probably know. So yep, I had to teach the front end people who work for me. Says don't touch anything. If it looks like it's a high speed design, ask everything, because you don't want to get an SI person irritated at you.
Oh yeah, yeah. God, that's the last thing that I think fabs need, because they're working to try and make sure that you get the highest quality and it's manufacturable and everything. But if suddenly it makes the design non-functional,
Yeah.
who eats it? Does the
Yeah, I
customer
teach
eat it, or does the factory eat it?
factory always eats it.
Yeah,
I'll tell you that right
yeah,
now.
exactly.
Where does a customer say, "Oh, you're right, I messed up. I shouldn't have put that on my drawing." Actually, a few years ago, we had a DFM for a company, a large customer of ours, and we sent it in. We found an aperture that was round in the data, and it was rectangular on the print, or I mean oblong. It was a slot. So we sent it back. Okay, here's what we found. It's a DFM. We're months ahead. Are you going to send it to us? Well, they replied back with two different answers. One person said round, one person said slot. So the engineer just put it away in the file. A few months later, the data shows up. Well, he accidentally grabbed the wrong one. He knows he should have looked at both, but he didn't. Grabbed the wrong ones. We built it wrong. We built with a hole that really did want a slot. Of course, we got the corrective action. The holy hell broke out, and the people came in on the corrective action. I wrote in the corrective action, which the way I was trained, corrective actions are to find the root cause. So I wrote in the root cause. The engineers sent us two conflicting answers to our TQs. You were the root cause. Oh, they didn't like that at all. So, well, you are the root cause. We didn't make the mistake. You did, And we can't say that a lot of times. The root cause always has to be the factory. It can never be the person sending the data. And that's the thing we need to change in the industry if you really want to improve. Because if you don't know you have a mistake, you can't correct it, right?
Yeah, whenever there's a mistake, whether it's design or a build, I mean, the fingers start pointing.
Sure.
So
you roll
quick.
downhill. Yeah.
That's unfortunate that it rolls downhill to the factory.
Yeah, I wrote an article for iConnect 007 design one time talking about corrective actions. So one of the fatal flaws in corrective actions is this 24-hour rule. You have to reply within 24 hours. Factories will reply in 24 hours. It may not be the real root cause. They will reply with something. You get a check mark. Good job. You replied quickly. Sometimes it takes a week or two to really figure out what happened, because there's enough checks in the design side, the designer's DFM side, the CAM process, and all the training, all the automation created to not have a single point failure. Typically, it's usually 3 or 4 things all occurring at one time for the first time. And when you try to respond just quickly to check out a form and a Pareto chart for your quality rating, you're getting a lot of bogus corrective actions. Everyone is. And that's not just Asia, that's in general. And sometimes you need the OEMs or the CMC to say, take your time if you need it. Okay, don't do it in every job, but if you say you need more time, take more time. Let's really figure this out. I've seen that a lot, more than I care to talk about. It's amazing.
So, maybe we can bring this full circle just for a moment, right? You're working for Nano Dimension, which, as most people should know by now, is an additive manufacturing of electronics focused company. And we've talked a lot about packaging in recent episodes. And now the industry is talking a lot about Ultra HDI, since some of those capabilities are very slowly but surely moving back to the US and Europe and probably Canada as well. So how does the data exchange or data transfer issues that we've been discussing, how do those change when you start to look at some of these more advanced areas? Now we're not just looking at kind of the vanilla 2-layer PCBs that have some incorrect pads or paste mask or whatever. Now you're talking about something that's much more advanced, and I think fabricators can be much more hesitant to start playing around with the data just in the name of manufacturability. So how does all this process and how do these issues change when we get to more advanced technology?
It's a very interesting question. So typically when a new technology comes out, the fabricators never really built it before. They're just getting process equipment developed. There's a lot of interaction with the customer. Okay, here's the design rules. Here's our real capability. We work back and forth. either through FAEs or CAM or process engineering or a team of people, will work a lot trying to figure out what the best rules are to match the process, and also adjust the process to match what the requirements are. It works both ways, including materials and chemistries. So when you're first doing them, I always call design rules have three levels. There's standard, advanced, and development. So standard is you can run a board through a factory. No process engineer has to ever see it because it just runs standard high yield, whatever high yield is for that technology. Then you have advanced, which is a standard board with a couple things that are maybe a little bit lower yield or take a little bit more tuning, but we can still run it through the factory without process engineering watching every single part number. And then development is I haven't released a process yet to release it to standard. So process engineering has to babysit it through a factory. And they're developing the process while they're working with the customers to figure out the requirements. It's a very interactive step. So typically the data will come in okay because everyone's really closely tuned on that, but the process may not work right. Okay, so we have to adjust something. Okay, we work together on that. But if you look at, let's assume Ultra HDI, which is really in high volume in Asia already, is running full blast. What's different? When I get down to tolerances, thicknesses and tolerances become more and more important. Like we went from 4G to 5G. We went from, I remember in the 80s when I was chairing the IPC high-speed design guide activity. Back, I'm talking about early 80s. I used to get phone calls from fabricators. What's a TDR? What's impedance? Okay, I've never seen it before in a print. Okay, now we get into, I call the 5G space for argument's sake. Well, now it's mostly an SI problem. It's a loss problem, not an impedance problem. So you have to worry about the tolerances of everything. And so you have to pay a lot more attention to how much everything you do from a tolerance standpoint could affect the signal integrity of that circuit. So you have to worry more and more about tolerances. What are your real min maxes and how tightly can you control them? So if you look at Ultra HDI, there's some of these newer, 25 micron, 35 micron type technologies. It's really how tightly can I control those so I don't have shorts or they get too close to each other from a coupling standpoint or whatever. So it's more, you need to understand the tolerance of the process and the process combinations before you go release the product to manufacturing.
So if you're a designer and let's say you're going to be designing something that can only be fabricated with, UHDI processes, it sounds like it's still your responsibility to not just know the line width and spacing, but maybe there's a little bit more responsibility you have, which is to know things like tolerances, to know things like press out, to know things maybe a little more detailed in the stack up than you would typically do with an HDI board.
Right.
In order to ensure that, number one, you just meet the design rules, but number two, that you generate a data package that doesn't appear to be correct when it's incorrect, or that just has all the correct data that the fabricator needs to more quickly get this into production.
Right. Like if you go to signal integrity, you got to worry a bit about the construction of that 4 mil core. What glass style is used? Is it spray glass? Or what glass style are you using versus let the vendor pick whatever he wants? That could throw off the simulation entirely. It's still 4 mils, but it's a totally different structure when you get to that frequency or that bandwidth. Yeah. So it's just more you got to just really, in my DFM class, I teach people it's really important to go in and understand the capability of the vendors you're working versus the rules that you're going towards. And try not to get too many of the very high-end attributes in a board shop because they're always going to have lower yields. It's just in human nature, equipment nature. So you want to try and make sure your product is going to capabilities that are more centered for what you're trying to do. If you go outside of that, just be aware of it and work with them closely. They'll want to work with you. No one wants to build scrap. No one likes to build scrap. So if someone gets beat up if they build scrap.
Yeah. Maybe just to wrap up our discussion, if you could give us an idea of where the industry is going to be going next regarding data transfer, data formats, and if there will ever be anything beyond IPC-2581 that could help everyone do their jobs better.
There really is between 2581 and ODB++ from a data standard standpoint. They're very good. They contain a lot of intelligent information about that trace, so you can start eliminating drawings. Quit eliminating duplicates. the data formats actually are in good shape is use the power of them. That's what people are lagging on. Is everyone has to do a fab print. Well, to me, I can print a fab print using some software at the end of the day, okay, to send to the floor. Whatever picture they want, we can create that from the data. You don't need to send the data on the fab print and have conflicting things. So the main thing is get out of the habits, like say it's like more than 15 years, it's probably 50 years, we have to send a print. We have to send a drawing. We have to, I call it e-paper. Yeah, it's electronic, but you have to print it out and someone has to type it in. That's basically paper, just in a different format. So I think if the industry could just start not creating duplicate stuff and use the intelligent formats that are there, we can have massive improvements in data transfer because they're both bi-directional. And you can link stuff better. And you have to worry about if something quits, you lose all knowledge, what you did in the past. Like, I don't really see there's another, what can we do better? It's like, if we just do that, that'll be the 80-20 rule, right? Solve 80% of the problems.
Yeah, it sounds like this is a lot to do with just designer education.
And software too. Not all software implements every function of a data format. And so they need to
Okay,
implement
that's fair.
everything. Yeah, on both sides. And then the users, the fabricators need to use all the functionality. It's not just the creating, it's the using of it also. It goes both ends. Yeah, because they're
Those
pretty
are all
powerful.
great
They're pretty
points.
powerful systems actually, or definitions I should say.
Yeah, those are all great points. And well, hopefully, as all of this continues to develop, and maybe as more designers need to learn more about these data formats and how to use them, we can have you back on and can talk more about these issues.
Sure, yeah, we can get people to get you into the gory detail of the code if we want to do that. So it won't be me, it'll be somebody else. But yeah, be happy to talk more about the format. Yeah, definitely. I'm a real
Absolutely.
believer this will help solve a big problem. That's why I'm pushing this for over 2 decades now. So yeah,
Absolutely, absolutely. Well, thank you so much for joining us today. To everyone that's out there listening or watching on YouTube, we've been talking with Dana Korf, AME Standards Manager at Nano Dimension. Make sure to hit the subscribe button if you're watching on YouTube. Leave a comment or question in the comment section. And if you subscribe, you'll be able to keep up with all of our episodes and tutorials as they come out.